So folks, now I want to review the three different equations to a line that we've studied in our pre-work videos. So the first one, and maybe the most important one, I think, is the point-slope form. And that's an equation form that usually students are a little less familiar with, and I'm really trying to push you to get comfortable with it because you're going to need it all the time in your calculus career and beyond. So an equation to a line is said to be in point-slope form if it's written as y minus y1 is equal to m times x minus x1, where m is the slope of the line, and this x1 comma y1 is any fixed point. So there's the y1, x1. That's any fixed point on the line. So I want to show you where this comes from. If we go back to our equation for the slope of a non-vertical line, it was m is equal to y2 minus y1 all over x2 minus x1. So let's let x2 comma y2 be the variables. That's the word variables. X comma y. So if I were to take that point slope form of the line, I would get m is equal to y minus y1 all divided by x minus x1. Sorry about that. And then if I were to multiply this denominator over to the other side by rearranging, we would get m times x minus x1 is equal to y minus y1, which we could then rearrange into the traditional y minus y1 is equal to m times x minus x1. And it's important to know that of all the different forms, generally, point-slope form is the most useful for building the equation. Let me convince you of that. In this example here, we're asked to find an equation to the line passing through the order pair 3 comma negative 4 with a slope of negative 1/2. So this would be y minus a negative 4 is equal to minus 1/2 times x minus 3, where 3 is playing the role of x1 in our formula, negative 4 is playing the role of y1, and negative 1/2 was being played by m. In fact, let me color code that just a little bit better here. Different color here for the y1. So there was our y1, there was our slope, and there was our x1. Of course, we could rearrange this. I'm perfectly happy with this if I just ask you for an equation of the line. We could rewrite it as y plus 4 equals minus 1/2 times x minus 3. Another great place to park your answer. Or we could even do some rewriting here. If I put it into slope-intercept form, we'd have y is equal to minus 1/2 x plus 3/2 minus 4. There we'll have to add some fractions, but we get y is equal to minus 1/2 x, and 3/2 minus 4 would be 3/2 minus 8/2, or negative 5/2. And here I've put it into a more form that some students are more familiar with, the y equals mx plus b form, which we'll talk about next. I will say just one more time, because I find that students have a hard time with this, I believe that the point-slope form of the line is the most important form of the line that we need for calculus. It's also the hardest of the three forms of the line to describe to students, and sometimes they're reluctant to learn it, especially because they know some of the other forms so much better. So I'm really pushing you to learn this point-slope form of a line. And here it is. Let's give that equation one more time. Here is the point-slope form equation of a line. This works for any time we have a line with defined slope. We can't use the point-slope form for vertical lines. Okay, so let's keep going. Let's go ahead and look at the slope-intercept form, which is the form written in y equals mx plus b, where m, just as before, let me use the same color, where m, just as before, is our slope, and the order 0b is the y-intercept. So I want to point out that if we go back to that y minus y1 equals m times x minus x1, where this is for any x1 comma y1 on the line, I specifically know that 0b is the y-intercept, so I could take and plug the ordered pair 0b into this point slope form. So we know 0b is on the line. And so we can write this as y minus b is equal to m times x minus 0. And here I have used the point slope form of the line, but I specifically have plugged in the point that is the y-intercept. And if I rearrange this, we get y is equal to mx plus b, that familiar point slope form. And a lot of students find that as their favorite form of the line. And I will say that the slope-intercept form is useful for graphing the line. It has its place. I will reiterate, though, that you do need to get comfortable with both forms of the line for your calculus classes. So let's see how this is useful. Let's go ahead and graph the line y equals 3/2 x minus 4. So the first thing I'll do is I'll go plot the y-intercept. We can read from this straight off because of the, just by lining things up, that our b value is -4. And so the y-intercept is always the order pair 0, comma b. In this case, we would have the order pair 0, comma -4. So I could go plot that y-intercept right there. Then we also know that the slope of this line is 3/2, reminding ourselves that the slope is the ratio of rise to run, change in y to change in x, as long as the change in x isn't 0, which we like to think of as the expression rise over run. So I'm going to go 3 units up for every 2 units that I go over. So if we go up 1, 2, 3 over 1, 2, there's a second point on this line, where what we did is we went up that ratio. We rose 3 for every 2 that we ran. And we could continue. And you can see I could plot several points because slopes can maintain that common ratio. Slopes of lines anyway maintain that common ratio. And there we've got the equation of that line, which we've graphed. Finally, folks, the last thing to remind you of is that we had the standard form of the line, which we've already looked at. It's the form that can be written in the form ax plus by equals c. We had that on the previous page. But here we assume a, b, and c can be any real numbers, but a and b are not both 0. Okay. And sometimes, I think I probably ought to backtrack this. Some books, the book that I wrote this out of, assumes that a is positive. This is case by case or book by book dependent. Okay. Standard form is useful for finding intercepts. So for example, here I've got an equation of the line in standard form, 7x minus 3y equals 21. And let's go ahead and find the x and y intercepts. So when I go to find the x-intercepts, I'm going to, and folks, I'm sorry, the only way I know how to show this without being physically present is to cover something up and then we'll solve. So to find the x-intercept, we let y equal 0. So folks, don't clutter this up, or I guess I could write it here. 7x minus 3y equals 21. What I'm going to do here is that I wouldn't actually recopy this equation. I would just, with my hand, cover that expression, y, right? Because if y is 0, then the expression minus 3y vanishes, and I'd be left with the very simple equation 7x equals 21, which gives me x is equal to 3. So we always knew that the y-intercept looked like something comma 0, and in this case we found that that x-coordinate was 3. If we want to find the y-intercepts, we would let x equal 0. And so what I would do is just with my hand, and I can't demonstrate this to you via video, but with my hand what I would do is I would just cover up. If x is 0, this first term would vanish. 7x would be 7 times 0, which vanishes. And if I solve that equation in my head, I would get y is equal to -7. So we always knew that the y-intercept was going to look like 0 comma something. That's what it means to be a y-intercept. But we just found that the y-coordinate of the y-intercept was -7. So folks, I'll just reiterate that you're responsible for knowing these three forms of the line. You ought to know why they're useful. Standard form is useful for finding intercepts. Slope-intercept form is useful for graphing. Point-slope form is useful for building the equation of the line. And there is room for a little bit of overlap between those three rules. They're not hard and fast rules, but hopefully you see why we teach three different forms, because we have many different types of questions we ask with lines, and sometimes one form is better suited than another. I want to point out these other facts too. We have our special cases, which are important to keep in mind, what we mean by lines of zero slope, undefined slope, and the definitions of parallel and perpendicular, and our review of the basic idea of rate of change. So folks, this is our last pre-work on equations of lines. I hope that this was helpful, and we will be doing some skills quizzes on this soon. Thank you very much, folks, and I'll see you next time.